then we can proceed to another presentation, copper nanoparticles, impregnation of anti-coronavirus COVID-19 disposable protective masks. So I guess the presenter is going to be Margraf.
Yes.
Yes, Mr. Margraf.
Are you hearing me? Oh, yeah.
Yes, we do hear you.
Oh, no, thanks. I will ask your permissions for turning off the camera so it maybe can improve my connection quality throughout the presentation.
Okay, no problem.
Can I do that? Oh,
yes, absolutely.
Oh, thanks. So I'm going to start. I'm begging to share my screen now. Here.
Yes, absolutely.
Yes, here. A little bit. I'm going to stop my video. Are you seeing my screen now?
Yes, we do. You could have directly shared your presentation. You didn't have to go on but it doesn't matter. It works anyhow.
Okay. So I'm going to start. So
no, it's perfect.
Okay, so as you're seeing, the title of the work is Copper Nanoparticles Impregnation Method on Protective Mask Fabrics. And here is me, Gabriel Margraf, and there is Beatriz, Luci, Fernandes, and Percy, Nohama, which is my oriented. The introduction. The moment in which humanity lives nowadays needs the convergence in the efforts of the academic community aimed at the innovation or improvement of techniques that will help to fight against the COVID-19 pandemic, as well as others to come. And in this scenario, it is indispensable accessory is the disposable protective masks used by health professionals and the population in general. However, in addition to not promoting the total retention of particles, it does not provide elimination of microorganisms. Therefore, based on the reports of scientific studies, as well as in historical and contemporary empiricism on the effectiveness of the use of copper as agents to combat viruses and bacteria, we performed an experiment aimed to develop new copper-based particles impregnation method and fabric pieces of disposable protective masks. Here you can see some historical evidence showing that copper has been used for millennia against the proliferation of microorganisms since ancient Egypt. Even without knowing the existence of viruses and bacteria, since from Hippocrates' time, from 400 years before Christ, it was already noticed that the use of copper and utensils and coatings efficiently reduce the incidence and the proliferation of disease since antiquity. And here we can see some contemporary uses, realizing that bactericidal and virucidal effectiveness of the metal. Patents were registered as soon as the production of equipment and with utensils with copper and silver in the composition began. Here we can see an example of copper being used in Chilean hospitals to reduce infection rate among the patients. It is clear for decades that microorganisms proliferations reduced significantly using copper instead of steel, justifying the extra investment. And here in Brazil, we can see some examples from the Cobrex, which is an adhesive manufactured and implemented in the Rio de Janeiro urban transport, and even clothing with silver particles from the Maui brand being produced and sold on national soil. These products are on high demand in the market worldwide, revealing the need for innovation. So we can see here in the proven of effectiveness of the copper nanoparticles, after centuries of development and improvement of scientific methods and equipment, the pragmatic superstition of yesterday becomes a scientific fact. Thus, as technologies such as electron microscopy are applied in the experiments involving copper as a sterilizing agent, its effectiveness is proven through the degradation of the glycoprotein membrane of viruses and bacteria when in contact with their ions, consequently destroying them. Well, the contemporary masks, such as the surgical PFF or N95, despite filtering at least 95% of the particles circulating in the air, do not eliminate the viruses and bacteria, which can survive up to 3 days impregnated in the fabric. However, we need copper to purge these microorganisms from masks, thus lowering the risk of infection. However, how do we apply it on it? So the objective of this work was to evaluate production process of impregnation of copper nanoparticles in non-woven fabric, TNT, a core material used in all kinds of protective masks nowadays. The methodology, we isolated copper particles from copper sulfate solution with constant heating in a volumetric flask, simultaneously impregnating pieces of TNT cut from commercial disposable protective masks. Here you can see the process and the images of this experiment. As the fabric pieces were removed and left to dry in an oven for 24 hours, and after dried, the fabric pieces were placed in Petri dishes and sealed to avoid contamination. Samples of the TNT pieces were analyzed by SEAM, scanning electron microscopy, and EDS, energy dispersive spectroscopy, after impregnation of a gold layer by PVD, physical vapor deposition. And the results you all can see here. The electronics microscopy images and the figures below show the formation of the impregnation of copper particles over the fabric fibers and the particles in the detail, respectively. The size of the particles varies from micro to nano scales, revealing the success of the used method. And here you can see the images of magnification and amplification, respectively. The analysis shows the presence of copper particles over the TNT piece, as you can see here in this posted images. And here you can see that it is indeed copper. The results show the mass proportion of the element is around 1% relatively to the gross weight. And you can see here other elements as oxygen and carbon to be around 27 and 72%, and around 1% of copper, which we will discuss the safety reasons later. Despite the success of the fabrication and impregnation method, not all the fibers of the fabrics were covered by the copper particles. We were able to notice it visually too. So some adjustments must be done to improve it. And one of the main problems that we see is that the particles tend to agglomerate, affecting the efficiency and dispersion over the entire mask, similarly to the results obtained in other experiments, where the metal particles were unevenly spread across the test surfaces. To solve such a problem, some dispersing surfactants can be tested, as done by the researchers in King Saud University in Saudi Arabia, aiding alpha, beta, and gamma cyclodextrins into the fabrication of the copper particles to avoid agglomeration, thus decreasing the size and improving the spread of the material throughout the test surfaces. And another point noted is that the particles deposited over the fabric fibers are majority microparticles and not nanoparticles, similarly to what experiments of this sort have done in the past. However, we did not find scientific reports indicating that to be antimicrobial, the particles must be at nanoscale. Therefore, the particle size interference can be an analysis for future studies. The health controversy described in the first article of this article it is evident that copper is an excellent means of antimicrobial prophylaxis, being used for millennia for this purpose. Furthermore, its contemporary use in hospitals and objects of common use as a means of mitigating the contamination of diseases has shown consistent results, empirically corroborating for the improvement of the discussion on the subject in the academic environment. And therefore, the use of copper in manufacture of no personal protective equipment, such as respirators, gloves, socks, and other objects, should become increasingly common practice in the industry in the coming years. However, it is necessary to emphasize that the effects of copper particles when in contact with the human body are still poorly studied, with several types of diseases being related to both the lack of copper and its excess in the body, indicating that caution and moderation should be determining factors in the future of the production of protective equipment with copper in its composition. The next phase we are developing now regarding the health issue controversy that we seen a while ago, and furthermore, the rather imperfect results obtained in the first phase of the experiment, we're making another project in parallel to this one to achieve the same ends, but by different means. An electrostatically copper-active filter is being developed and produced by our team as an alternative to the particles impregnation on the fabrics. In short, We're creating another fabric made of copper itself, which can be attached on other fabrics or even masks. To assure that attraction and further elimination of the microbes. Which of the two methods will be proven the most effective? We don't still know yet, but we're going to find out in the next months. So the conclusion that we came is of the present research, the results are promising and deserve further studies to improve the process parameters through change in solutions concentration, use of native cyclodextrins and surfactants, and improvement of the time and temperature to obtain uniform particle size, to avoid particle agglomerations and allow better distribution of the particles all over the TNT fibers. Also, the process is of low cost, easy to be done, and can be scaled up to produce disposable protective masks with extra and safe protection from pathologic microorganisms. And so it is over. Hope you all enjoy it. And thanks for being here with you today. And you can speak of any questions you would like. Thank you.
Thank you very much for your nice presentation. Exhaustive and interesting. Topic is very up to the date, very actual. Does anybody have any question?
Yes, I have one, Desna.
Yes,
sorry.
Please.
The first one, first of all, congratulations on, very innovative and interesting approach to the mask. And my question is, as these are, disposable mask, it does make, what is the cost difference? So this is basically, there is no specific.
It is totally neglected. It is a small difference from the normal masks because the process is so of low cost, then the entire process does not even double the cost of common masks. So this is why we chosen this method of nanoparticles instead of other expensive methods using another prototype masks today.
And the follow-up questions, so others also have opportunity. General, what is a typical attitude toward mask in Brazil? Because United States, there are a lot of protests against masks. Some are people who are, pro masks, and even when they are not required anymore. Of course, we know that in Asia, China, Vietnam, other places, masks are acceptable. Yes. So one thing is basically, what is the attitude of a mask when it comes to Brazil? Just curiosity, yes.
Some part of the population are accepted about their effectiveness. I cannot estimate a number exactly, but I've known even certain health professionals that won't use masks in the works, and therefore they lose their jobs because the general thought about the subject here in Brazil is that to follow up the science worldwide, and some individuals cannot be so how can I say responsible for the think of the entire country. Here in my region, I see around 95% of the masks being used at all times, even in closed spaces. And the subject here is to the how can I say, to the educated people, is to follow the science in general and not to believe in WhatsApp groups and messages from people that don't know what they're talking about. So the majority of the people respects the national recommendations for health, and that's it.
Are these masks washable like any other mask, and or it's basically makes the difference, or you didn't test at this stage yet?
Oh, we didn't test it yet, and we are in it's a work in progress. We are testing it now, and in parallel with this project and the another project that I mentioned in the next phase of the project.
Yeah. congratulations again on very innovative and different approach. Yeah.
Thank you very much.
Thank you.
It has been a pleasure.
I'd like to make a final question. Can
Fabiano.
I?
Yes.
Congratulations, Gabriel.
Thank you.
My question, you said that copper in contact with human tissues is still poorly studied, yeah?
Yes.
But do you intend to conduct research about this topic?
No, we have done a scientific literature review in this topic, and we found out that the majority of the researchers tend to believe in that we need more studies to evaluate the efficiency of the copper when in contact with the human skin. But some minority of the researchers related to this mask topic, and which are developing new technologies the same as mine, tend to believe that in the quantities that copper is present in these masks, and even if their entire content of copper are would be getting to the lung of the user of the masks, even with the entirety of the content of copper would be in the lung of the patient, it would mean no significantly harm done to it, because the quantities are minimal, and we do this process in a way that the copper cannot go past it makes it difficult. The copper goes beyond the other layers of the masks. But even so, we are doing there's another project is with a solid copper structure, and this solid copper structure mitigates the impact of any copper getting into the air, into the lungs of the user. So we are concerned about the health too. And so that's why we are extensively testing it at the present moment.
Okay, thank you for your answer, and congratulations again.
Oh, thank you. It's very kind.
If I may add also, we can keep in mind that actually our plumbing, yes, is being changed from galvanized steel to copper piping, yes. So with this, hopefully, there is no side effect, because we drink water all the time. I do not know if in Brazil it's the same thing, that water plumbing is changed to copper, or it still is.
Yes, it is indeed made of copper.
Yeah, so it's if this is right, that's a good news. Yes, okay, yeah.
Yes, we came across in the systematic review about this topic too. I have seen some articles about this topic, and it contributed to the consistency of the systematic review.